I decided to begin the Powerwheels RC project by listing individual goals that I feel are important to have it perform as expected. The first of these goals is to be able to power the car with the 20-volt DeWalt battery packs that I already have available. This will add convenience to recharging, and the switch from the 12-volt Powerwheels lead-acid battery to the DeWalt 20-volt lithium-ion battery will provide more power at a much lighter weight. My second goal is to be able to control forward and backward motion using a remote control system. I bought a Traxxas transmitter and receiver to be used in adding remote control to the car. The next goal is to be able to control the steering system remotely. This is going to be a little more difficult than acceleration because it will involve using a linear actuator with its own controller wired into the system. I think that it'd be a good idea to have a power switch on board, but I haven't decided yet between a toggle or a rocker switch and where exactly I would place it. Since lithium-ion batteries can be damaged if discharged too low, I'm going to use a low voltage cutoff to protect my batteries. I'll be setting this low voltage cutoff to about 15 volts, which should disconnect all power to the car before causing any damage to the battery. Now that I've gone over the goals for the project, I'm going to go over the materials and create a simple diagram to show how they'll be used. So the diagram is starting with the power supply, which I'll be using a 20-volt battery pack for. Next in line will be the low voltage cutoff. From there we move on to controlling the drive motors. For the drive motors I'm using the Sabertooth 2x25 motor controller. This speed controller is intended for brushed motors, which is what I'm going to be using, and it is rated for 30 volts, so we'll be fine using 20 volts for this system. The pins along the bottom in the diagram are used for connecting the battery and the motors. In the center are the positive and negative for the battery terminals, and then on the left and right are the positive and negative connections for each of the two motors. To be able to tell the motor controller what to do, I need to send a signal from the receiver. So that'll be connected to the opposite side of the Sabertooth controller using a positive, negative, and signal wire. Next on the diagram will be the two drive motors that are controlled by the Sabertooth controller. I'm just going to be using the stock Powerwheels drive motors for this, at least until they fail. To control the steering, I need to branch off of this between the battery and the Sabertooth controller. I don't want to bypass my low voltage cutoff because I want everything to be cut off if my voltage is under 15. So I'm going to place the Actuonics linear actuator controller right between the low voltage cutoff and the Sabertooth motor controller. This controller will then be wired directly to the linear actuator and not only be used to control it but also to power it. This is a Fergelli Automations linear actuator. It's sensored so that it'll return to center automatically, and it has a 2-inch throw with 35 pounds of force. Now that I have all the main components of the project, there are a few additional pieces that I needed to make it all work. One of these is a 3D printed adapter for the DeWalt battery packs to then wire it into the low voltage cutoff. The adapter has blade connectors that tap into the positive and negative on the battery pack. Then I can connect the wires wherever I need them. The next problem that I'll need to solve is that the Actuonics linear actuator controller only can be powered with 12 volts. My system right now is 20 volts, so I need to figure out some way that I can convert the power from 20 volts to 12 volts so that I don't burn up my controller. I decided to use a 24 to 12 volt DC voltage converter to reduce the voltage to 12 volts and prevent damaging my linear actuator controller. For power distribution, I got a terminal strip to make it easier to split between the controllers for the steering and the drive motors. on this I'll have input for positive and negative, and then 2 output leads for positive, negative to go to the controllers. Okay, so we came up with a plan, but now we're going to lay everything out and wire it up to make sure everything works before we actually start installing it into the car. So this is our adapter for the battery. Before I put any power to it, I want to make sure that I have it into the correct place. So on the cutoff, the low voltage cutoff, here is in, and negative is labeled on this side, positive here. So bring the black wire in for negative. Tighten that down, make sure that we don't over tighten it too much and strip it out. Positive here. Now we should be able to try the first test. So I'll slide the connector into the battery, make sure that it goes in properly, and according to our low voltage cutoff, it says that we have 20.1 volts. Okay, next is to hook up our terminal strips for power distribution. And 20.2. So we have the same reading, both at the power distribution strips and the low voltage cutoff. So that part's good so far. The next thing we need to do is connect our motor control board to the positive and negative here. Brush motor controller to power. Negative here. Positive. Now we can test to make sure that we have power from our battery pack. So we have power from the battery pack to the low voltage cutoff to the terminals, and we have a blue light showing that we have the motor controller turned on. Just to verify, we can check the voltage into this, and it's at 20.2. So everything's good to this point. So next we're going to wire in the receiver. Before wiring this in, I want to make sure that the voltage out for this receiver is actually 5 volts. So I can test that here. Try tightening the bolts up to see if they get better connection, because right now I'm getting nothing. And after tightening them up, I get 5 volts. So I can loosen these back up. Then I will connect the red to the 5 volt, the black to the 0, which is negative, and the white, I actually stripped a small portion off so that I can use this wire as a bridge to connect signal 1 and signal 2. Make sure that you don't forget to turn the power off when you do this. when I connect the power, we now get a light to the receiver. So the next thing that we're going to be testing is using the transmitter. Make sure that when we pull the throttle, the voltage is going to change on the motor controllers. So both of these should work together. We'll test motor 1 first. So it says that we have 14.7. If I pull the throttle, it changes to 12.4. If I reverse it, it goes up to 18.7. So if I flip these around, now if I pull the throttle, I get 14.9 volts. If I release the throttle, it's down to 0. Reverse it, it works. And we'll try the opposite motor to make sure that it works as well. Throttle, release, reverse, it works. We're going to connect the 24 volt to 12 volt converter to our terminal strip. That way we can then use the linear actuator controller. I want to check and make sure that I did succeed in reducing the voltage to 12 volts so I don't fry the steering controller. And it's 12.3, so that should be fine. Now to connect the steering controller, the negative and the positive for input are going here. Next, we are going to wire the linear actuator into the linear actuator controller. So, starting with blue at the top, the order is blue, black, red, yellow, white. So blue is here. Okay, so there's what it looks like. To control the steering, we have to connect the receiver to the controller. We already have 12 volts coming into this. We do not want to add 5 more. So for that reason, don't connect red to the receiver here and here. Instead of using one of the 3 wire connectors that you would normally use with a receiver, we'll just use black and white, so ground and signal. That way there won't be a chance of accidentally connecting another positive wire. So on the board, black's going to be negative. Slide that on. RC is going to be the signal. So we'll slide that on as well. Both of those on, then we're going to connect the negative and the signal to the receiver. So even though we're using the regular Powerwheels motors and not replacing them with these, just for demonstration for wiring this together, I'm going to connect 2 motors to make sure the whole thing works. If the motors turn the wrong way once we have them connected to the gearboxes, all that you have to do is swap the wires on the control board. It will not mess anything up to hook them up backwards. Okay, so right now, steering works. Very gently, throttle. Throttle works, reverse works. The whole system is working. So here we have the power supply adapter and the low voltage cutoff. I cut off the original battery connector from here and ran my new wires through the same path back to the under the seat area, which is where we're going to be placing the motor controllers. Now we reinstall the wires, blue on top, followed by black, red, yellow, and white. Now we can reattach the power wires. So I cut a board that'll fit into this rectangular space, 4 3/8 by 8 7/8, and it just slides in. That way I can mount all of the components onto that board and keep them organized. everything's connected. It's time to test it out. Transmitter's on. Power.